Uh, Good evening to respected participants. Myself, Praveen Reddy, working as sales manager. It's my great pleasure to welcome you all for our today's technical session about how mycotoxins disrupt poultry immune response. Thank you so much to you all for participating into our online session despite of your busy schedules. From Town Nutrition India, today here we have our sales director, Dr. Brij Mohan, Feed Dietetics Director, Dr. Sujit Kulkarni, Technical Head, Dr. Sabiha Kadri, Marketing Head, Dr. Chandani Parihar, and her team member, Reena, my team member, Mr. Chandrasekhar, along with our today's presenters, Dr. Swami Haladi, Global Program Manager, Mycotoxin Risk Management. Dr. Swami Haladi is our Global Program Manager, Mycotoxin Management. He obtained bachelor degree in veterinary science and master degree in poultry science, especially in aflatoxins in poultry, from University of Agricultural Sciences, Bangalore, India. Later, he attended the University of Guelph in Canada, where he earned PhD on Physiodium mycotoxin. Now, I am welcoming and requesting Dr. Swami to start his valuable presentation. Thank you so much. Over to Dr. Swami Haladi.
Thank you, Praveen. Let me share my screen. Okay. Are you able to see the slides now? My screen?
Yes, Doctor. Please.
Oh, thank you. Thanks, Praveen, and thank you so much for everyone for attending. And I'm sure some of you we are quite familiar. As I worked in India for quite a few years and interacted with some of you. Unfortunately, I don't see who is all attending. But welcome again for all of you to this webinar today. And my colleagues requested that specific topic of mycotoxin-induced disruption of immune response because general impact of mycotoxins is very well known. But how do they really impact the immune response, and how can we manage the risk is something very important, given I think whole world is ruled by today the pathogens, whether it is corona, whether it is Newcastle, whether it is avian influenza. So we hear a lot of challenges from pathogens, which are very small creatures but can create a big havoc like what's happening today. So hopefully the discussion will help in making the management of the poultry better. So I will not go through about my background. So already Praveen has mentioned. So I have worked quite a bit in India, also in North America, based out of Canada, working for different organizations. Of course, I operate now from Bangalore. Although my role is a global role, but I was able to work. I'm able to work from home in southern part of India, Bangalore. So when it comes to the feed safety, which is of course is directly linked to the food safety, because the food is what we eat is what the animals eat as well. So if we provide a good quality feed to the animal, we can expect the good quality food for us and our family and children. So that's why the feed safety part is very significant for Trout Nutrition, right from the sourcing of raw materials all the way to the food production. So whether it is producing meat, milk, or eggs, today they've been more regulated for various reasons, for antibiotic residues in milk, or mycotoxins in milk, mycotoxin in eggs, pesticides in eggs and milk. So a lot of the gaps that are happening between the feed to the food that needs to be filled, and that's what we try to do as a company in the entire value chain. So coming to mycotoxins, mycotoxin is not a new topic, and particularly for India, it is not a new topic, because we all know that a lot of scientists have worked in India on different aspects, right from the I think from late 70s to 80s, because of the kind of impact the mycotoxin can have on farming animals. And it is relatively easy to do the mycotoxin research in India, unlike in the Western countries, a lot of restrictions on the use of animals. So that is also one of the reasons why a lot of research has been carried out in India over the last 3 decades. So today, as we speak, there are more than 600 mycotoxins that are known to us, but for ease of understanding, for ease of analysis, we focus on the big 6 mycotoxins. The big 6 being deoxynivalenol, or DON we call, T2 toxin, zearalenone, and fumonisin. All these are fusarium toxins produced by the fusarium fungus, whereas aflatoxins and ochratoxins can be produced by Aspergillus, which is a very common problem in India. And penicillium toxins, again, we have ochratoxins, which can also be a significant threat. So if you see there on the slide, ochratoxins are produced by both Aspergillus as well as penicillium fungus. That's why sometimes in India we do this toxin quite often. And of course, the ergot toxins, which is more problematic in dairy cows, but also there are some incidences of ergot toxins showing up in wheat, barley, sorghum. May have an impact on poultry as well, but not very well studied in this area. So the next question is, how do we know that there are mycotoxins? There are many methodologies today. What we focus in terms of nutrition is a very quick, reliable, and rapid method of analysis. We call it as a MycoMaster. It is based on the lateral flow technology. So there is a very little chance for the error, the laboratory error, the technician error. So that is why we use that, and we are able to connect these MycoMaster to our central database from all over the world, and then it helps the producers, the feed millers, the farmers in optimizing their monitoring of the quality control. They can adapt the formulation. If the levels of mycotoxins are too high in some countries, they may have to lower the amount of that particular raw material they're using. And of course, they can also help to decide what kind of toxin binder to use, how much to use, and those decisions can be made using this MycoMaster and the supporting mycotoxin advisor tool. So there are various methodologies that have been used around the world. HPLC is a gold standard, a very good selective, sensitive methodology, quantitative, but it is very expensive. It takes a lot of time to do the analysis, and most of the places we don't have those facilities. LC-MS-MS is even advanced methodology, much more sensitive than HPLC, but again, very expensive to do. It costs like, I think, $250–300 per sample. So that is the limitation. But yes, it can analyze many more mycotoxins. So that's why the ELISA came into picture for quite some time now, based on the antigen antibody reaction. But again, ELISA, the disadvantage of ELISA is that it has to have a good laboratory setup. You cannot just do it in a feed mill, air condition. It has to be dust proof. All those things are very important. Some question of possibility of cross reactivity, pigments intrusion, and all these possibilities are there. Matrix effect. That is why lateral flow device technology has come into picture, which is reduces all these challenges in terms of the specificity. So it's very convenient, sensitive, very easy to operate. Even basically, honestly, it doesn't need an education. Even a 10th grade kid can run this analysis. So that is one of the advantage why a lot of feed mills would like to use such kind of methodology to analyze for mycotoxins. Again, it is quantitative, so it gives you the defined quantity of mycotoxin that is present in the feed or the raw material. So we use these MycoMaster. We have quite a few, I think 12 or 13 MycoMasters in India today, in different parts of India. So, we get quite a good data. So far till the end of June, the analysis shows that aflatoxin contamination percentage is about 89%, fumonisin around 85%, and ochratoxin is about 95%. So again, as I mentioned to you, the ochratoxin, the chances of picking up is higher because it is produced by two different fungus. One may be in the storage, one may be in the field also. So that's why we are seeing high levels. We do test for T2 toxin, DON, and Zaralanan, but we haven't seen much of those toxins lately. But when there is a suspicion, we definitely do those mycotoxins as well. So what we saw was the aflatoxin on an average we found around 27.7 ppb, which is more than 20 ppb, which is a limit. Fumonisin around 1300 parts per billion, ochratoxin around 16 parts per billion. Just for your note that ochratoxin is much more toxic than aflatoxin in poultry. That is based on the LD50 results we got. So even a 16 ppm of ochratoxin can already be toxic to poultry. So just if you look at different feed types, layer feed, broiler feed, we all see mycotoxin to different levels, somewhere ranging from 2015 to 2031 parts per billion, different toxins. So fumonisin was around, on an average, around 1,780 ppb. So we do also have a tool called Mycotoxin Monitor that won't be very specific to a customer, but definitely it gives an overall picture of the country. This is definitely Praveen can show this to you guys. You can choose a particular country. You can choose a raw material. You can choose a date for 1 month or 2 months. Even in fact, we can go by weeks also. Start looking at those numbers. It will also give you the information about whether that feed or the raw material is toxic to poultry or not. So that kind of a tool is also there. So we'll be very happy to discuss with you further if that is of interest to you and your customers, your farmers. And as we all know that mycotoxin toxicity is comparable to cancer, because like cancer, mycotoxin impact is happens over a long period of time. Acute toxicity is very seldom seen in the market today, in the field today. So you see a chronic toxicity of low levels of mycotoxins fed to the birds for a long period of time. The trouble with the diagnosis of this is there are no clear animal symptoms because it is a combination of toxins. So it's very difficult to have a clear symptoms for mycotoxicosis. And the levels are also low levels of mycotoxins. So if you look at individually, you tend to feel that they're low, probably they don't deserve a closer look. A limited number of mycotoxins analyzed in the feed, as you can see. With ELISA, we can do 6 mycotoxins. Of course, if you use LCMS, you can do 300, 400 toxins, but that is not practical because when a truckload comes to your feed mill, you need to make a very quick decision to accept or reject those raw materials. So with that short period of time available, it is not possible for us to do an extensive analysis. There are some forms of masked mycotoxins which are not able to be detected. And of course, there are interaction between these two toxins. Some toxins, there is a additive interaction. That means the presence of aflatoxin and ochratoxin, the concentrations, you can add them together to come to a conclusion. Or synergy, sometimes just adding those two aflatoxin numbers, ochratoxin number is not good. You need to multiply that by 2.5, 3 times in order to get the realistic exposure. So that is why, by looking at various regulatory or guidance values around the world, the limits set by FDA or European Union for mycotoxin limits are very high. They are not set keeping in mind the animal performance. They are keeping in mind mostly the raw material procurement, raw material movement. So that is why it's very difficult for us to take those numbers into consideration for animal performance, because if you wait for those limits, already the animal performance is affected. Just to give an example, DON limit for European Union is for poultry is 5,000 ppb, and we already know that 500 or 1,000 ppb of DON already can cause problem in poultry. So that's why we need to develop some practical guidance values, and those practical guidance values what I have developed based on some science and also based on my experience. If you see the table on the right hand side, very luckily we have a nice information available for poultry. The LD50 values, lethal dose 50 values are available. So for ochratoxin A, it's a 2.1 milligram per kg body weight. For T2, it's 5.1. For aflatoxins, is 6.5. Whereas for DON, it is 140 parts per milligram per kg. So by looking at that, we can easily set up a practical guidance values based on that. The aflatoxin is 20 ppb. By taking that as a standard, we can able to fix the practical guidance values. So these are the numbers here for, we have divided poultry into chicks and mature poultry, because as you know, the chicks are not able to tolerate high levels of toxins. They're toxic. The liver system is not very well developed. The digestive system is not very well developed. So you can see those numbers there. Aflatoxin between 5 to 20 parts per billion as a low, medium, high risk. DON between 225 to 450 for chicks, and 450 to 900 for mature poultry. ZIA, honestly, birds can tolerate very high levels of zearalenone. So I wouldn't spend a lot of money in testing zearalenone in poultry. Ochratoxin is somewhere between 7 and 14 parts per billion, very toxic. Fumonisin between 900 to 1,800 for chicks, and 1,800 to 3,600 for mature poultry, and DON T2 between 16 to 32 parts per billion. So definitely we can share this with you, which might help you to set up a limit for mycotoxins in poultry. So coming to a bit of a topic on the today's topic is an immune response, and you might wonder, why I am talking about the impact of mycotoxins on gut health. And as you all know, that 60 to 70% of the immune cells in chicken are present in the gut. So that's why it's very difficult to separate the gut health from a immunity point of view particularly in case of poultry. So because the mycotoxins are present in the feed, and mycotoxins are passing from mouth all the way to the end of the large intestine, the epithelial cells are constantly exposed to these mycotoxins. In the entire gut, they are exposed to these toxins. And when they're exposed to these toxins, they cause a lot of disruptions. Maybe in case of aflatoxins, it's very well known that it affects the intestinal barrier function. In case of ochratoxins, again, it increases the intestinal permeability. That means more and more mycotoxins and pathogens can go inside the blood. T2 and DON are known as cause the increased intestinal permeability, lower tight junction proteins, along with many other effects. Fumonisins also known to alter the intestinal barrier function. So overall, the main effect of mycotoxins on the gut health seems to be on the tight junction proteins, intestinal permeability, and that's why it is important. We consider that gut health promoting ingredient is very important in our mycotoxin binder concept. So if we don't manage those tight junction proteins, of course, on the left side, you see a nice normal tight junction proteins, but on the right side, you see because of the inflammation, the tight junctions are broken, and then the toxins and pathogens can get into the lamina propria, then to serosa, causing a lot of problems. So leaky gut can also be caused by mycotoxins. So if you move from gut health to the immune responses, it's a very complex topic. I'm sure most of your veterinarians on this call, you all know. I don't want to go down too much in detail, but the immune system is divided into innate immunity and adaptive immunity. And the innate immunity is the first line of defense. That means, without the exposure to the pathogen, these defense mechanisms are already there. It can be saliva, it can be natural killer cells, macrophages. So these are all the cells that are involved, or the mucus production, or hydrochloric acid. These are all examples for innate immune system. There is no immunological memory for the innate system. That means if the same problems comes next time, the bird has to work again to have the right amount of innate immune system there. It doesn't have any memory. If you go to the adaptive immunity, it's the second line of defense. It is very, very specific to a pathogen, antigen specific. Once the pathogen comes, there is next time it is exposed to the same, there is an immunological memory. That's a good example is corona, what we are all facing through. If you do the if a person is exposed to the corona, or if there is a vaccination, then the body cells, immune cells can remember and protect us better when the infection comes back to us. So a lot of B cells and T cells are involved in this process. So specific to the chicken immune system, you all know that it starts from the Harderian gland in the eyes, thymus, spleen, bursa fabricius, Peyer's patches, and gut-associated lymphoid tissue. Again, 60 to 70% of the immune system there. Production of IgA is very critical, and bone marrow, all these play a role there. And you can see on the right side the involvement of antigen presenting cells, T cells, B cells, cytotoxic cells are all involved, macrophages are all involved in enhancing the immune system. Again, we know by practice, by science that at the hatch, there will be antibody transfer from the mother to the embryo. So there is some protection from the maternal antibodies. Then it starts going down, of course, after the hatching. So that's where the acquired immunity has to come up either through the vaccination program or through the natural exposure to the pathogens. So there is that time immediately after the hatch, or early part of the life cycle of the chick, where the immune system is compromised, and there is the phase we really need to be careful. How do we manage the chicks? So how does particularly the mycotoxin affect the immune responses? Similar to the gut health, there are very specific actions for aflatoxins. A lot of studies have shown that they affect the phagocytosis by the macrophages. They suppress the delayed type hypersensitivity, cell-mediated immune response, the poor antibody titers. Those are all there. In case of ochratoxin, the regression of lymphoid organs, poor DTH are all very well known. T2 toxin, regression of bursa fabricius, lower amount of leukocytes, increased disease incidences, they're all known. Whenever you have T2 problem, DON problem, you tend to see more salmonella cases, more E. coli cases in chicken. It's a very good correlation. Even coccidia has an interaction with these mycotoxins. DON, it interferes with antibody production, RNA synthesis, DNA synthesis, so overall the antibody titers will be poor. The fumonisin, similar effect on the liver, spleen is expected. So just some pictures. I'm sure most of you know these. Effect on liver, effect on spleen, and the bursa size also reduces. And one important aspect is liver is one of the biggest immune organ in the body. A lot of people, a lot of us don't think that way, because we think liver as a organ to break the toxins or pathogens. But a lot of the pathogens from the blood, they carry to the liver, and there is a lot of sampling of antigen that takes place in the liver. So liver is an important immune organ. So if the liver damage is there, definitely the immune response will also be compromised. So the antibody titers, good example. This is from India. The study we did in 2019 when we exposed the birds to 250 ppb each of aflatoxin, ochratoxin, and T2. This is done by Professor Malathi at Bangalore Veterinary College, and we can see the decrease in the antibody titers for both Newcastle disease and IBD titers. And here I want to make one additional point, is because since the immune system has got both cell-mediated immunity and antibody-mediated immunity, I think as an industry we really need to come up with one good marker for cell-mediated immunity, because we measure the antibody titers all the time, but we don't measure the cell-mediated immunity parameters, which is 60% of the total immune system, even more than the antibody response. That is something I've been advocating quite a few places, but so far nothing much has happened in that direction. So I think as an industry as a whole, good to take that perspective and maybe standardize one methodology, like maybe delayed type hypersensitivity methodology for identifying the challenges in the cell-mediated immune response. So another quick example of how mycotoxins may affect the efficacy of antibiotics or drugs, because in this case, T2 toxin study was done with anticoccidial drug losolocid. We know that losolocid is very effective as coccidia. So when you use the losolocid, the mortality lesions came down. But again, when the T2 toxin started introduced, although high levels in this experiment, then again the mortality and lesions started picking up. So a clear indication that some of the mycotoxins can interfere with the efficacy of antibiotics and anticoccidial drugs also. So that is the impact. I wouldn't spend a lot of time on the control methodology, because I'm sure you guys all know that mycotoxin risk management is a very it should be an integrated approach, starting from managing the raw, how do we produce the raw materials on the farm, how do we store them, how do we produce the feed in the feed mill, and all the way how we manage the birds on the farm. All these 10-point system what I have created has a big role in a way to manage the mycotoxin risk. So coming specific to our product Toxo range of products, we have toxin binders. We have come up with a little bit of a different approach. We call this a 3D approach. We don't necessarily stick only to the binding of mycotoxins, because we know that all the mycotoxins are not possible to bind all the toxins. Just to understand the limitations of binding, we know that the clays such as the good quality bentonites, they effectively bind aflatoxins. They also bind ergotoxins, and to some extent the bacterial toxins or the endotoxins. We also know that they have a moderate binding to T2 toxin, Zea, and OTA, not a lot, around 40–50% of binding, and very little binding to DON, very well known fact. And also a lot of people believe that the clays can bind fumonisin, but with our experience, the clays can bind fumonisin at acidic pH in the stomach. But when that complex of toxin and the binder comes to the intestine, then the toxin is released back into the system. That means the toxin will be again absorbed into the blood. So that is not an effective strategy for managing mycotoxins. So that is why we feel, along with the mycotoxin binding concept, some gut health and immune modulatory benefits of the product would be very beneficial to the birds, especially in poultry, because the systemic effect of mycotoxins in poultry is much higher than in pigs, because the poultry continue to consume the feed irrespective of the toxin levels. So very quickly, not through a lot of time here. So binding, gut wall protection, immune modulation are our mode of action. And ToxoMX is our product, is mainly focusing on mycotoxin absorption, whereas ToxoXL has got all the three modes of actions. So more than 90% of aflatoxin binding has been achieved, and also a good, close to 91% binding with the endotoxins or the bacterial toxins. Also, the leaky gut I mentioned earlier, we have isolated a compound called glucose biopolymer from the cell wall of yeast, and that helps in tight junction, improving the tight junction integrity, so that the toxins will not get into the blood circulation, so the birds are protected. Now, one good example is we studied in Canada that deoxynivalenol or DON, we fed around 6,000 parts per billion or 6 ppb to 6 ppm to birds. We saw a significant reduction in the height of the villi to the crypt depth. That means the integrity of the villi is affected, and when we add our product, the ratio went up, showing that the ingredient is capable of helping in those challenges. So, and another aspect as an immune modulator, you know very well that the beta 1,3 and 1,6 glucans are very well known immune modulators. So that is also a part of our product, and we know that it is very difficult to separate them. That's why we use an enzymatic hydrolysis methodology, so that we don't break the beta glucans. So that has been very effective for us. And we compared a lot of products in the market for the ability to stimulate the macrophages, and you can see on the right side, irrespective of the ratio of beta glucans to the protein ratio, our product was toxo beta glucans are much more efficient in stimulating the the yeast cell walls, in this case macrophages. So once you have the macrophages stimulated by the beta glucans, and then they can kill the bacteria because by the phagocytosis. That is more of a natural protection mechanism. Also, they can have an impact on the B cells and the T cells to produce both the specific antibodies and non-specific immunoglobulins. Both are important in their own way for protecting the birds. So I'll just give two examples of the product we use, ToxoXL. Again, the study conducted at Dr. Malathi's lab in Bangalore. So we use 250 ppb each of these aflatoxin, ochratoxin, and T2 for 42 days. You can see the control at a body weight, end weight of 2232 grams, and it reduced to 1924 in the toxin group. And with the product, it improved to 2018 grams and 2062 grams. FTR also significantly increased by the toxin, then they were reduced by the product at both the doses, showing that the product was able to protect the birds. Similarly, antibody titers both for IBD and ND are improved at both the levels of inclusion of the product. So we calculated the return on investment. So depending upon the level of inclusion, I also remember that we use the high levels of binder because the toxin levels is also very high, 250 ppb each toxin. We hardly see 50 ppb or so in the field. So definitely that was an important aspect. So on an average, a 3-to-1 return on investment we were able to see in this trial. Last study from China. This is in layers, so applicable to breeders in a way. Here we compared with the negative control, no toxins, but positive control with 150 ppb of aflatoxin B1, 1500 ppb DON, and 120 ppb ochratoxin A. And then we used our product at 1 kilogram per kg, and also two of the competitor products also we used, which are quite popular in the market. And you can see there, egg laying rate was decreased almost by close to 6%. And then with our product, we were able to improve that. The competitor products also improved, but definitely less significant than our product. And FCR was also improved by our technology, whereas the competitors were unable to improve the FCR. So the return on investment we calculated here, again, it was similar to our broiler study. It was coming around somewhere around 3 to 1 return on investment for India. So this is the study was done in university in China. So with that, I would like to conclude that latest research on mycotoxins in livestock and poultry has shown that both gut health and immunity are significantly compromised by multiple toxins. And research also over the last 2 decades shown that mycotoxin binding alone is not sufficient to manage the multiple mycotoxin risk. And so we believe and are proven in many cases that along with the binding approach, anything that can improve the gut health and immune response also is very important to protect the birds from the mycotoxins. With that, I think Praveen, back to you, and I think we have a demonstration from Avinash.
Yes, doctor. Thank you so much for giving valuable insights. Now, our next speaker is Mr. Avinash Bhatt. He has over 20 years of experience in analytical laboratory analysis and R&D. He has been a co-author in several peer-reviewed research papers and co-patent holder for the development of anti-mastitis vaccine in cattle. Now, I am welcoming and requesting Mr. Avinash Bhatt to demonstrate about our innovative mobile mycotoxin analysis instrument, that is MycoMaster. Over to Mr. Avinash Bhatt. Please kindly start your demonstration.
Thank you, Praveen. Thank you, Dr. Swami. So, and again, good afternoon, everybody, and welcome to the demonstration for the MycoMaster. This is our trump card. You say that it's a good tool and a quick analysis tool. So we carried out all over the globe. So this is a MycoMaster. This is the main instrument. It's just a handheld, and also it's a part of a kit of the MycoMaster kit. It's a field kit. So it consisting of a small, apart from that, a centrifuge. It consisting of a centrifuge and also a small grinder, and also it involves a small weighing machine as well. Apart from that, there will be the sample cups and micropipette, centrifuge tubes. So these are all the part of the kit. So it comes as a field kit. So now I am going to demonstrate. The demonstration time normally it will take around 20 minutes for the complete analysis of a single mycotoxin. So now I will show you going to show you demonstration of the sample. So that's a poultry feed. That's a feed sample. So we have to weigh 50 gram of sample. That's a standard procedure. So we are going to take the 50 gram of sample and weigh sample in this cup, and also it can be tightly closed. So we have to add. There is an extraction powder. So this is a extraction powder also comes with. So you have to tear it, then add it to the powder. Then we have to add a distilled water. If it's distilled water is not available, so this is again 150 ml of distilled water you have to add. If the distilled water is not available, so you can add clean drinking water also can be added. So like RO water, so distillery water. So 150 ml you have taken and just close this lid. Then shake it for 2 minutes. So this is a 2 minutes shaking is necessary because just I am demonstrated. Already the sample has been made. So this is the extraction. So now available. So now we have to take the sample. So we have to take the sample and centrifuge it. So I'm going to take 2 microcentrifuge tubes. So 2 microcentrifuges and going to centrifuge it. So this is a, here I am going to use here, this is a yeah. This is the centrifugation. So you have to perform it for 40 seconds. Around 45 seconds, you have to perform it. So already the sample has been centrifuged for the purpose. And so after centrifugation, so you have to take the sample into, that's the syringe filters. So the syringe filter. So you have to use the syringe filter and take it into, so we have to take it and filter it. So this is now, this is the extract. Now this already I made the extraction. So the extraction is ready after filtration. So now what we have to way to take is, there is a so what I'm going to demonstrate is for actually aflatoxin. So we have to take a buffer, a dilution buffer for aflatoxin. This is a dilution buffer and aflatoxin. This is a dilution buffer. Normally it is been written AFQ dilution buffer. So normally we have to keep it this dilution buffer in the refrigerator always. So I have taken, so 600 microliter of this sample. Then I am going to take another fresh micropipette tip. So this one, so already the extraction is available here. So this is the extraction. So from this one, I am going to take 300 microliter of the extraction buffer. So this is a 300 microliter of extraction buffer. So this is what I'm going to take and mix it with already taken 600 microliter of the buffer. Mix it properly. Now this is our extraction is ready. Now I'm already switched on the MycoMaster. So in the MycoMaster, so if you can see here, there's a menu. So first, when you are starting the day, so you have to perform the, so whether the instrument is working fine or not. There is called a performance monitor. So there is a, they have given an calibration strip. So this is the calibration strip. So it has got a one light pink and another one is a dark pink side. So this will be used for the calibration check. So now, so yeah, I'm just going to press that one as a calibration check. So it is asking me because there will be display will be there. So you have to first insert with the dark one. Click OK. So now it's analyzing, the instrument is analyzing whether the instrument is working fine or not. So the reading says actually it is working within the range. Now this is now I am going to take the high calibrator. That's a light pink side. So you can see here. So now this is a, also you can see the values also can be measured. So now this is everything is fine. So this instrument is working fine. Now we can go ahead with our analysis. Okay, now this is the LFA strip. So there are different, this is a LFA strip. So here there is a sample pad. There is a sample pad here. And here actually the movement will be more sample we are going to add on the other side. So we have to flip open here the strip. There will be sample groove is there, sampler. So there actually we are going to add the sample, and there's a color coded. It is a color coded for individual recognition of individual mycotoxin, because if this is having a purple color, so it will recognize when I insert the strip, it will recognize it's aflatoxin. So this is immediately afterwards, actually a test, aflatoxin test will be. So we have got here around 40 different commodities can be measured. So you can select. So this is the unique feature of our MycoMaster. So you can select the different around 40 different raw material and feed commodities. So this is a broiler feed. So I am going to select for a broiler feed. So this is a broiler feed. So when this broiler feed is there, so it will automatically ask me. So enter. Actually, details enter we have to do. The first one is actually entering the operator ID. So you have to give the operator ID. So then it will ask a sample ID. The sample ID normally, if the lab is having their unique lab IDs, that can be given. So I will just give it for as a demo. Then if you have got a lot number, so lot number also can be entered, and also from the country, because if you know the country of origin of the sample, so that can also be entered. So here, then also the supplier, so name also can be entered. So now, so here also inside it's an incubator will be there. So it will tell you that whether it's a temperature, when it's a green color normally. So you can see here. So a green color, so temperature is now 45.1. So now green color indicates now this is the sample is ready for the sample intake. The sample we have to take is a 300 microliter. So I am going to take the 300 microliter of the sample. So already the sample is already ready. So I am going to take 300 microliter of the sample. So I'm taken 300 microliter of sample. So this is a flip. So you have to flip open here. So there is a groove is here. I already told you that how to, and immediately close it. So it will take 5 minutes to run the sample. The final result will come in 5 minutes. So this is about the MycoMaster. So after 5 minutes, the analysis result will be displayed.
Thank you, Avinash.
Thank you. I think there will be short video is also available. So you can see the short video. It's also clearly you can visualize the details. So all steps are covered in that video. So Rina, can you run the video?
MycoMaster is a unique mycotoxin rapid analysis portable reader that is easy to use and ensures accurate on-site analysis. The complete MycoMaster kit can be used in any location without the need for a third-party laboratory. You can quickly analyze the 6 most common mycotoxins: Afla, Dawn, Zea, Ochra, Fumonisin, T2HT2 within 10 to 15 minutes to ensure quick decision making. Take 50 grams of the sample in an extraction cup. Add 1 sachet of extraction powder. Add 150 ml of water. Close the lid, shake it for 2 minutes. Allow it to stand for 2 minutes. Take the extract into the micro centrifuge tube. Centrifuge for 45 seconds. Pass the extract through a syringe filter. Take a fresh centrifuge tube, add 600 microliters dilution buffer, add 300 microliters of extract. Switch on the MycoMaster. Carry out the calibration check. Insert the fresh mycotoxin strip. Select the sample type from the menu. Enter the sample details. Load 300 microliters of the sample into the strip. Close the MycoMaster lid. Wait for 5 minutes. The result will be displayed on the screen.
Thank you, Dr. Swami and Avinash, for your wonderful presentations and demonstration of our MycoMaster. So here we enter the Q&A, question and answer session, and I would like to request Dr. Swami and Avinash both to switch on their cameras for the question and answer round. I would also like to thank all the attendees for being actively participating and sending in their questions. So here I will just ask the questions from the forum. So Dr. Swami, first question is for you. Fumonisin B1, what toxin inhibitors to be used and what are the clinical signs?
Fumonisin B1, it's one type of a fumonisin toxin. It's a group of fumonisins. Is a group of toxins, not one toxin, coming from a Fusarium fungus, predominantly found in corn and corn byproducts. We don't see a lot in other raw materials. In terms of symptoms, in poultry, we don't see very obvious symptoms, as I mentioned to you before. Some of the things they can observe is effect on liver, spleen, reduced in the immunity, because some of the studies done have shown that whenever there is fumonisins, they increase the chances of E. coli, salmonella colonization. So more of a gut health and immune response effect. So it doesn't cause obvious feed intake or FCR issues. You need a very high levels to cause that. So more on the health side, fumonisins are a challenge to the birds. Whereas if you look at pigs, yes, even at low levels in fumonisins can cause a lot of issues in pigs, but in poultry, more at the gut health and the immunity level, they have problems.
Okay, thank you, Dr. Swami. There is one more question on how can we identify chemical toxicity? What is the line of treatment for the same?
Okay. See, the chemical toxins generally in India, they refer to the pesticides, insecticides, those kind of things, the chemicals that are used to spray on the crops or the grains while storage. So those are called chemical toxins, I believe, although the name is not very accurate, but that's the word we are using in India. So those they are not intensely studied in effect on poultry, but some of the studies have shown that drop in egg production, maybe egg quality issues, some anecdotal effects on the performance of the broilers also. So far, I have not come across any solid solution against these. People are talking about using charcoal. Of course, charcoal can bind anything. You have historically we have been using if there is a even snake poisoning, people use the charcoals, or some other kind of very acute poisoning, people use the charcoal. But charcoal can absorb anything that comes in between. So it's not very specific. The chances that it can bind nutrients and antibiotics and anticoccidial drugs, as I mentioned to you before. So yes, charcoal can be effective, but you will have to see the level of inclusion and making sure that you're okay even if it binds some nutrients. So you need to add more nutrients to the diet to prevent the mortality, and then use the charcoal. So apart from that, I don't see a lot of technologies coming out in that. People claim that clays can also bind them, but there is no research available on that. So they might bind a little, but how many? There are hundreds of pesticides, insecticides. If you go to any other good laboratory, if you ask for pesticide analysis, they will give you a list of 200, 400 pesticides. I don't think anyone has done any binding studies with toxin binders at this stage. Yeah, that's where we are today on that.
Thank you, Dr. Swami. What is can only absorption strategy counter all mycotoxins?
No, I think I was very clear in my presentation. It's difficult because of the structure, various structures of mycotoxins. It's very difficult to bind all the toxins. So that is why I think what we mentioned about identifying the gut immune modulation, even looking at antioxidant status of the animals in the field, that is also an angle to look at. So those are the supportive treatments are important. So I was also under the impression that in the past binding wood is enough, but I think more and more research coming today, people are also accepting that it is not a possibility, and we need to look at more sustainable integrated approach to manage the mycotoxins, not only preventing but also to some extent treating the birds organs also important.
Okay, thank you, Dr. Swami. Next question is for Avinash. What is the sampling procedure, or how to send the samples to laboratory, to trial lab?
Possible to unmute from your side, Rena, Avinash, or no?
Okay.
Yes.
I will add a question. The sampling here. So any samples around 200 to 250 grams, the samples we need. The sample has to be properly labeled, because because MycoMaster can recognize the different the commodities, particularly broiler feed, layer feed, or whatever the different commodities. So clearly mention, okay, what type of the commodity, because the labeling is very, very important. Sometimes the people are sending the samples without proper labeling. So this is going to be again difficult, because now actually the calibrations are normally carried out, taken based on their different commodities. So with the commodities being given particularly specified, so that will help actually to get a good result. So this is a one important thing, so that we have anybody has to, when you are sampling sending the samples, the proper labeling is going to be very, very essential. So we need around 200 to 250 gram of samples. That will be we are going to analyze using around 50 to 100 grams of samples will be taken for the analysis.
Okay. Thank you,
Yeah,
Avinash.
and this is since poultry is a dry feed arena, we don't need any refrigeration and things like that. But yeah, whenever we used to have microbial organisms growing, silages and those things, we do expect some other way of sending samples. But for mycotoxins, as long as it is dry, nicely packed, that should be good enough for us to reach.
Okay, thank you for the explanation, Doctor. Dr. Swami, the next question is for you. And since we are running short of time, so we will take 2 more questions before we wrap up. So the next question is, what are the major heavy metals? And can we analyze pesticides in feed?
Yes, yes, of course. The major heavy metals would be arsenic, lead, I think a few more like cadmium, I believe. So some of those are heavy metals being used. Yes, both heavy metals and pesticides can be analyzed. I use sometimes a lab called TUV lab, which can analyze 200 to 400 different pesticides. You need to mention to them what kind of ingredients. So they also recommend you, if you are using maize, these are the pesticides to be analyzed. If it is soybean meal, these are the pesticides. So you need to mention the purpose. So those can be done, and they can approach the TUV lab. And Avinash, you also know SGS, TUV. Is there anything else, Avinash, who can do those pesticides?
Yeah, there are. Now because there are so many other laboratories are also available. One is in Hyderabad, in the Vimta labs also doing the job, and Eurofins is also again they also can do. But the thing is actually, so in my experience, so many times though already many of the labs actually standardized for pesticide analysis for water. So not many people have standardized their analysis for the feed samples. So the feed samples, the preparation maybe actually sample preparation is going to be very, very critical in this case. So from the water it will be easy, but the feed samples are not really easy. And in my experience, I think many laboratories, they standardize their process for water, not for the feed. So only I think specialized only some laboratories maybe who are export. So they may be doing that kind of a job, because they will be very, very critical when you are exporting, particularly antibiotic residues and also for heavy metals. Heavy metals can be done, of course, for any, but the pesticides residues also, they have to be very, very critical analysis has to be done. Only some of the export the oriented people, they have their own laboratories, they perform, and some central laboratories, so they perform this analysis.
Yeah. Right. TUV, as I have good experience so far. So yeah. Yes. Thank you.
Okay. Dr. Swami, the last question for today would be, what are the effects of mycotoxins on the reproductive system?
Okay. In case of poultry, most of the studies are focused on hatchability, fertility and hatchability. Though, of course, eggshell quality in breeders, if the eggshell quality is affected, then a lot of more of the exchange of oxygen from inside egg to the outside, so you lose that, and the embryonic mortality has been observed. So eggshell quality, fertility, hatchability, and number of chicks produced, those were the main things studied. For aflatoxins, they are studied. For ochratoxins, T2, Dawn, also some people have studied. So yeah, those were the major impact. But I also would like to mention, as I mentioned in my presentation, the level of Zeralanan we found in India, or for that matter in the world, is not big enough to cause a problem in poultry. So I request you not to spend a lot of money on testing the Zeralanan in poultry feeds, but in pig feeds we need to analyze that. In fact, me and Avinash, we put together an article. We found even up to 80,000 parts per billion of Zeralanan was not causing any problem in poultry. So that is something we want to give you a take-home message. You can also go and refer papers, but certainly I would recommend not to do the Zeralanan testing, because again it costs money. Each sample Avinash would cost 800,000 rupees. So it's important to wisely use the analysis for that matter.
Okay, great. Thank you for the explanations. I would once again like to thank all the attendees for actively asking all these questions, and thank you, Dr. Swami and Avinash, for your insightful answers as well. Now I would like to invite Dr. Sujit Kulkarni to give a vote of thanks to the entire audience. Thank you.
Am I audible, Rina?
Yes, Sujit, we can hear you.
Yeah. So a really very insightful presentation by Dr. Swami, and also a very nice demonstration by Avinash, my colleagues. I think very interesting, very vast subject. I think sometimes when we discuss, I personally also, whenever I discuss with Dr. Swami, we realize that the time is short and so many topics on the mycotoxins. But still, I think the way TRAU is studying on that, the R&D, what we do, I think that is more important. It is a big subject of understanding and education and learning also, that what is the impact, how many mycotoxins are there, what are different analysis method. As Dr. Swami told, from ELISA, HPLC, LCMS, everything is we do as a TRAU nutrition. And also on the spot, we have this MicroMaster analysis which demonstrated by Avinash. So I think it is a pure, I always say it's a prevention program and insurance program. We have to make the proper insurance. It is very difficult sometimes after analysis also to predict the level of the different mycotoxins. So, and second thing, even despite of low level, sometimes subclinical mycotoxins is the major issue in India, because what happened, unless and until too much high mycotoxins is there, you can't see the clinical symptoms of mortality. But subclinical mycotoxins is the burning issue, or I can say more than 80 or 90% subclinical, where the bird's health deteriorate, immunity is hampered, and that is impact on the dominance of whether it's a bacteria or virus, which can be get dominant, and it can show the symptoms of the viral disease or bacterial diseases. But most of the time, root cause are the mycotoxins. So, all respected audience, thank you very much. Again, thanks our speakers, both speakers, Avinash and Dr. Swami. I would like to thanks organizers Praveen, Chandrasekhar, and our marketing team, Dr. Chandni, Reena. I'll also thanks technical team, Dr. Sabia and her team, and then from commercial side, Dr. Preet, and all our supportive team from the office and other my colleagues. So thank you very much.
Thank you everyone. Bye bye. Take care.
Thank you everyone.
Thank you to all. Thank you.